Welcome students, I hope all of you will be fine. Today I am going to discuss the all formulas used in the general physics as well as in the thermal physics with their applications. So first of all, I want to tell you about it that formula have 1 mark. Say right. So first of all, from the measurements, in measurements we have only formulas. I'm going to share with you one formula when we use the micrometer, and when we use a micrometer we use a formula. Let's suppose there is a micrometer and you are going to find a thickness, diameter of the ball. So there are the two scales. One of them is a main scale, another is a circular scale. Main scale is this one. This is a main scale, 0, 1, and this one is 0.5 is 1.5. This one is a circular scale. Let's suppose starting from 20, 21, 22, 23, 24, 25. The least count of the micrometer is 0.01 millimeter, and the formula used to find the diameter or thickness of the object is this one. Reading, you can find the formula main scale reading plus circular scale reading times least count. Main scale reading is from this scale, that is, you can see that is, let's suppose 1.5, and the circular scale reading is how much, which division exact meet with this datum line. This is a 22. So 22 is a circular scale reading. Then by using these two readings and by put the values of the least count, you can easily find the reading. The second thing, you can find the time period of the pendulum. In pendulum, you can see, let's suppose if there is a pendulum and the pendulum is vibrating forward and backward direction, so you can find the time required to complete this oscillation. And time period for this, you can easily find the time period by using the formula times of multiple vibration divided by number of vibration. Let's suppose you are going to find the time period. In such a case, you are going to find the time period of the 20 vibration. So you will find the time of the 20 vibration, and this time will divide by the number of vibration, that is 20. Then you can find the time period. The second thing, in this chapter you should know the prefixes. There are the 5 prefixes, and you know the values of the all prefixes, that are mega, kilo, centi, milli and micro. The value of the mega is 10 to the power 6, kilo 10 to the power 3, centi 10 to the power minus 2, milli 10 to the power minus 3, micro 10 to the power minus 6. This prefixes helps you to convert one unit into another units. The second thing we discuss in the measurements, how can you find the volume? You can find the volume by using the formula as well as in terms of the density, and you can also find the volume of the irregular shape by using the displacement method. You can find the volume of the regular shaped by using the formula of the shape. For example, volume of the cuboid is length into width into height, in this way. But another formula, you can use the density is equal to mass over volume, and you can find the volume as well if you know the mass and if you know the density. You can find the density if you know the mass and volume as well. You can find the mass if you know the density and volume. One thing should be clear in your mind: for the specific object, the density will be the same. For example, if I ask you the density of the water, the density of the water will be same throughout the world, but the density of the iron may be different from the water. But density of the steel and iron, let's suppose, may be different, but if the material is same, then the density will be the same. I think this one will be clear to you. The second thing, we can find the mass by using the physical balance, beam balance, electronic balance as well. You have also a formula to find the mass, and you can find also the weight. In the measurements, the formula is weight is equal to m into g, where weight, units of the weight is a Newton because it's a force. Unit of the mass is kg, and the value of the g is 9.8 or 10 newtons per kg or meter per second square. By using this formula, you can easily calculate the weight, you can easily calculate the mass as well. You can also find the gravitational field strength on a planet if you know weight and the mass. The second thing, in kinematics, there are the two graphs that are very important graph. One of graph is the distance time graph. In this graph, distance time graph, On the y-axis we have distances, on the x-axis we have time. And if in this graph there is a straight line, it shows the speed is a constant. If the gradient is increasing, we can say that the speed is increasing. If the gradient is decreasing, you can say that the speed is decreasing. And if the gradient is zero, for in this case let's suppose the gradient becomes zero, so we can say that speed will be the zero, or object will be in the state of the rest. And if the gradient is negative, how the gradient is negative? When the line moves in such a way, then the gradient will be negative. Then we can say that speed will be negative. And you can find the gradient, the formula of the gradient, you know very well. It is rise over run. Let's suppose in this case you can find the rise from the y-axis. Y-axis tell you how much the rise over there, and the run from the x-axis. So gradient of this graph, gradient of distance time graph represent speed. The second thing, the second graph we have is a very important graph as well. The graph is the speed time graph. On the y-axis there is the speed, on the x-axis there is the time. And again, the straight line in this graph, the gradient represent acceleration. If you want to find the acceleration from the graph, you will find the gradient. The gradient of the graph will tell you acceleration. Area under the graph tell you the distance covered. I think this one will be clear. The one thing, again, you have a straight line. If you have a straight line, it means the acceleration is constant, speed is increasing. In this case, speed is also increasing, but the gradient is increasing, so we can say that the acceleration is increasing. But in this case, in the graph, you can see that acceleration is decreasing. At this line, the acceleration is zero. Why the acceleration is zero at this point? Because the speed is constant, there is no change in the speed. But if the gradient is negative, we can say that acceleration is negative. Acceleration negative mean the speed is decreasing. So if you are applying the brakes, then the speed is decreasing, you can say that acceleration is negative. So guys, you know, very important. These two graphs are very important, and you can find the gradient of the speed time graph gives acceleration. Area under the graph represent the distance. But sometimes if you have no graph, you have the values only, then you can use the formula of the acceleration final velocity minus initial velocity over time. If an object starts from the rest, you can say the speed will be zero, and if an object hits a surface and comes to rest, then you can say final speed will be zero. In case of the free fall, always acceleration will be equal to 9.8 newtons per kg or 9.8 meter per second squared. The second thing, if an object is moving with the constant speed, then you can use the formula for the constant speed is equal to distance over time, or for the constant velocity equals to displacement over time. The second thing, you can also find the average speed by using the same formula. Average speed is equal to total distance or total displacement with respect to divided by time. I hope this one will be clear to you. Guys, then in the dynamics, the important formulas are related with some laws. For example, in the Newton's first law, Newton's first law says that if an object is in the state of rest or an object moves with a constant speed, then resultant force will equal to zero. It is the Newton's first law. But if the resultant force is not equals to zero, then Newton's second law describe that, let's suppose, is the forward force and the backward force are not equal. Backward force is less as compared to the forward force. 10 Newton is a forward force, 2 Newton is a backward force. Now the resultant force is equal to 8 Newton, and at this time the resultant force is not equal to zero. Then Newton's second law will come, and Newton's second law says that if the resultant force in an object, acceleration will produce in the direction of the force. And this is a formula to find the acceleration. Fr is equal to ma is a very important formula, and by using this formula you can find the acceleration, you can make the subject, and you can also find the mass. If you make the subject mass, then the formula becomes this one. So all these three formula comes from this formula. I think this one will be clear to you. The second thing, the third law is a very simple. Every action has reaction equal in magnitude but opposite in the direction. And the next law is the law of conservation of momentum. But before this, I discussed the law of conservation of momentum. You should know very well that momentum is the product of mass and velocity. If a ball is moving with some mass, with some speed, you can easily find the momentum by multiplying them. And the law of conservation of momentum is also a very simple law. And let's suppose I discuss the law of conservation of momentum. Before this, I am going to tell you the second formula of the impulse. Impulse basically is change in momentum, and then you can also say that impulse is also force multiplied by time, or in short you can say change in momentum is also depends on the force into time. And I'm going to show you how. Let's suppose if there is an object m1 is moving with the speed u1, and there is an other object m2, and let's suppose the speed of the object is u2, and m1 strike with the m2, so m1 applied the force on m2 for a short time, and due to this collision the momentum of the m1 and m2 will change. You can find easily this change in momentum of m1 as well m2 by using this technique, by using the formula impulse equals to force into time. If you know the force applied by the m1 to m2 and you know the time of contact, you can easily find the change in momentum. As well, you can also find the change in momentum of m1, and you can also find the change in momentum of m2. Let's suppose before collision the velocity of the m1 is u1, but after collision the velocity of the m2 is v1 and m1 is v1, and after collision velocity of m2 is v2. Then according to the law of conservation of momentum, the total momentum before collision will be equal to the total momentum after collision. So I am going to write over there total momentum before collision will be equal to total momentum after collision. And total momentum before collision will be how much? m1 u1 plus m2 u2 equals to total momentum after collision means m1 v1 plus m2 v2. I hope this one will be very clear to you. This is a formula for the law of conservation of momentum. And now you can see guys, the direction of the arrows are same. So I'm going to consider the positive sign with the velocity. But if the direction of the object will change, then you will change the sign of the velocity or speed. The second thing I'm going to share with you about the next formula is related with the Hooke's law. And according to this law, the force and extension is directly proportional. If you apply the some force on a spring, you can see that extension will produce, and this will be directly proportional to the elastic limit. But if the spring is stretched beyond the elastic limit, the extension will not be proportional to the force. For example, if I'm going to show you in the graph, force extension graph, and guys, very important thing, the read of the graph, बहुत important, the very important. You can read the graph. Let's suppose it's a straight line. If the line is straight, it means that force and extension is directly proportional. But after elastic limit, the line will not be straight. The extension will be more as compared to the force. This point is known as the limit of proportionality, or you can say that at this point the body is not elastic. You can also find the spring constant if you know the force, if you know the extension, by using the formula F is equal to KE. It's a very important. You can see you can find the spring constant as well is equal to force over extension. Now guys, the turning effect of the force or moment. Moment is of the two types, clockwise or anti-clockwise. And you can also find the moment by applying the simple formula force into distance, perpendicular distance. For example, if there is a pivot point, some forces are acting on this one. Let's suppose I'm going to show you some forces are acting on this F1, F2, F3. F1 is trying to turn this rod anti-clockwise. Distance of the F1 from the pivot point is D1. Distance of the force F2 from the point is D2. Distance of the force F3 from the pivot point is D3. So according to the law of principle of moment, you can say that if an object is balanced, so it means the forces are balanced. Forces are balanced means anti-clockwise moment will be equal to clockwise moment, and forces, how the force is balanced, you can see there are the three forces which acting in the downward direction, but some forces also acts in the upward direction, where the force upward act in the upward direction from the pivot point. And this upward force I'm going to mark with the red arrow will be the sum of all the three forces acting in the downward direction. I hope this one will be clear to you. As well, it means the forces are balanced. And if I say that moment are balanced, so anti-clockwise moment and clockwise moment will be equal. These two conditions of equilibrium, this one is a first condition of the equilibrium. As the forces are balanced, we can say that this condition is the first condition, and guys, this formula anti-clockwise moment is equal to clockwise moment is also known as a principle of moment as well as the second condition of equilibrium. Now you can see I'm going to show you anti-clockwise moments. How many responsible forces are there for the anti-clockwise moment? F1 is responsible for this at this time, so I'm going to write over there F1 D1 is an anti-clockwise moment, and for the clockwise moment the two forces F2 and F3. So for the F2 the moment is F2 D2, for the F3 the moment is F3 D3. So this is a formula for the anti-clockwise for the principle of moment. And you can also find the unknown moments or unknown values. The second thing, guys, you have the formula for the work and energy. The both things are the same, and you have the formula force times distance, but the distance should covers in the direction of the force. Or you can say that energy is also have the same formula, because work is proportional to the energy. If you know the force, if you know distance, you can easily find the energy. Unit of the work and the energy is the joules. And you can also find, guys, the power. Basically, power is equal to energy over time, work done over time. In place of the energy, maybe you have kinetic energy, because we have the further two formulas of the energies, potential energies. And one thing should be clear in your mind, time should be in seconds, energy should be in joules. Kinetic energy is the energy of moving object. You can easily find the formula 1/2 mv square, where m is the mass and v is the speed of an object. Potential energy is of energy stored in an object due to height, and it depends on the mass, gravitational strength, and the height, and weight into height as well. This one is another formula. So you can find the potential energy, kinetic energy, and the power and the work done by using these formulas. The one thing you know very well, efficiency. Efficiency is also the useful energy output to the total energy input times 100. And another relation between the output energy and the input energy, basically when you supply some energy to an appliance, that is the input, maybe electrical, output in the form of the light, in the form of the kinetic. Let's suppose some energy is a useful output, but some energy is waste. Normally sometime energy wasted in the form of the heat and the sound, but sometime heat and the sound is also useful in some process. But in case of the light, when you on a bulb, you provide electrical energy, and this electrical energy convert in the form of the light energy, but at this time you can say that heat energy will be lost. Then guys, in the chapter of the pressure, the basic formula of the pressure is equal to force over area. It's a basic formula. Let's suppose if an object is placed, if an force is applying on an object due to let's suppose there is an object placed and there is area of contact is given over there, force is given over there, then you can easily find the pressure by using the formula. The units of the pressure is pascals, the short form is PA. But one thing should be clear, the SI unit, force should be in Newton and area should be in meter square. The second thing, you can also find the pressure of liquid, and if you know the pressure of liquid due to liquid only depends on the three factor: density of the liquid, gravitational field strength, value of the G, and the depth height. If you know these things, you can also find the pressure of the liquid. But one thing should be clear in your mind, there are some also atmospheric pressure act on the liquid, that is a P naught. It is normally given in this the value of this pressure is given in the CIE's exams, 1 × 10⁵ pascals. So if you want to find the total pressure at the depth at this point, let's suppose I'm going to show you. If you are going to find the total pressure at this depth, you will add these two pressures, pressure of the liquid and the atmospheric pressure. But it depends on the situation, which quantity is asking. So the total pressure, you can find the total pressure as well, pressure of liquid plus atmospheric pressure. I think this one will be very clear to you. The second thing, guys, you know very well the another formula. If you have the two containers, in the one container pressure is P1 V1, but let's suppose if you compress the container, the pressure is inside is increased as volume is decreased. The relationship is inversely proportional, and the formula you can easily use over there or apply in this situation: P1 V1 equals to P2 V2. And you know why very well? The collision is increases over there. When the volume is reduced, the pressure is inside. The pressure inside is also increased. So if the collision is increases, you know the pressure is also due to the force, and you know very well the force is also have a relation. You know pressure is equal to force over area. You know very well the force is also equal to change in momentum of an object. So that's why the pressure is also exerted on at the wall or the sides of the container. The last thing I'm going to share with you, that in the thermal physics we have two formulas in the thermal physics. I'm going to share these two formulas because according to the updates of the CIEs, the latent heat of the fusion vaporization formulas are excluded from the syllabus. So only one formula, and I consider the two formulas in the thermal physics. One formula by which you can convert the Celsius temperature into the Kelvin, and very simple formula by which you convert the temperature in Kelvin to the Celsius. If you know the temperature in Celsius, you can convert the temperature in Kelvin by using this formula. It's a very simple formula. The second formula is for the specific heat capacity or heat capacity. For the specific heat capacity, we have a formula: C is equal to E over M delta T, where E is energy, M is a mass, delta T is change in temperature. And for the heat capacity, the formula is only E over delta T. So there are the two formulas you can use in the thermal physics. Energy can also express, you can make a subject of the energy. E is equal to M into small c delta T. And sometime you can also express the energy in the form of the power. Energy is also the product of the power into time, so you can also use this formula as well. So guys, the formulas are very important in physics. I have discussed all formulas with you using in general physics, as well as in the thermal physics, and in CIEs there is a 1 mark for the formula. Thank you so much. Take care.